All right. So uh, our DMA is not completing yet, and so I've done some research offline, and once again, if you always assume that your code is the problem, we're going to start there. So clearly up here, we have done a bunch of stuff. We're doing the OR symbol with this A address. There's our exception handler label. We're doing a few different things here. And so that caused me to think, you know what, let's find an example usage of this macro. And I'm actually going to take this a step further. So in the Peter Lemon repository, because he's nested the folders to multiple depths and so on and so forth, he went ahead and put a lib folder into each of the repositories. And so inside this lib folder is the actual code that is used for this example. So the first thing that I'm going to do, let's talk this through. This DMA is this macro, which is really what we've been looking at all this time. And so what makes this interesting is, so the DMA, the first parameter is the start, then the end, and then the destination. So the start is image. Well, in this code sample, and I love all of these code samples. This is an especially nice one. 25 lines, very approachable. Again, sometimes you have to look around. Many of his examples are quite long, but most of it's just font management code. Anyway, so this is a 25 line example. It's great. Here it says image, and then we've got the insert statement, which is a binary insert, which we've seen before, and that's what we're doing with our exception handler. Down here we have an insert statement, but what's this image word? Well, it's based on this usage, it's a label. Okay, so that label, that's nice, that's helpful. And then, so that was the start, and then the end of the DMA range. Okay, well, there's image, which is the same as our start, and then we're adding something. We're adding image.size. So, once again, like, here we've got this extra word on our insert statement, and then we have this dot size parameter. So, let's read more. And if we come over here, we see insert, there's a name, and then the file name. So the name is optional. That's the square brackets indicate. The quotes, it's a quoted string, and but it is not optional. So that's the only part that's required, and that's the only part that we're using up to now. But in addition, there's this offset and length option, which is rather interesting. So let's take a look at this. So let's see. The command inserts a binary file into the target file. You can optionally specify a name, offset, and length. If you specify a name, it will create a label by the given name, which contains the address where the data begins. And it will also create name.size, which contains the size of the included data. If you specify an offset, it will seek that far into the referenced file name before copying the data. If you want to specify a length, you must specify an offset first. By default, it would be 0. And the length will determine the maximum number of bytes to copy from the referenced file name. So, if we take that and let's kind of let's get a little fancy with this one. We'll say handler 1, comma, then our file name, and our offset is 0. But this is where we have our hex length of 300. Okay. And here's the thing. We no longer actually need either of those labels. So it really cleans up our code into this one line. And we can take this and make a second. 320. And this is a length parameter, so we're just going to say 080. Because from the 320, I believe all we've got left. So here, if we do, we're operating in hex, 400 minus 320, again in hex, is actually E0. Which is 224 bytes. So we actually want E0. So this is kind of interesting. It allows us to take the same binary file, break it into 2 pieces. You know what? We're just going to stick with that. Because I think we're going to end up with some really readable code. So, handler 1. We come back up here. And boom, done. Then, here, we go to handler plus handler 1 dot size. And now here, if we look back at the example, so he's not using that upper character prefix. And again, this is kind of hard to visualize, I feel, but we are sending this DMA command to the RCP, and the RCP really sees RAM, which is where we're writing this to, and that's where he was writing this to, is RAM. He was using the first megabyte, which is right here, which is actually his frame buffer. But we're going to write it to literally the 0 range, because that's what it is when we take off that top 8. So that becomes a really simple, clean little line. And again, we're still hopeful. I have not verified this offline. I just did the research and thought that this could really help our situation out, and a lot. Simpler code is always easier to maintain. So we're going to go ahead and, dare I say, be greedy and do both of these sets of code. I think that we just don't need all of those zeros up there. And that's just a lot of stuff. I'm going to be brave and delete it. In most cases, I would just comment it out and move on. So I'm going to do one more thing. And that is to literally copy this code, which, as I said, for this lib, inside of this lib folder, this is proven to work. And so, not that everything else isn't perfect or isn't the same, but this means that I'm going to use his original DMA. I'm not going to get fancy. So I really just cleaned up those lines a lot. The question is, do they work? And that's what we're going to find out. That is what we're going to find out. Okay, so unrecognized function DMA, exceptions ASM, line 22, that DMA. All right, so, oh, because I didn't save this file. There. Perfect. And now let's see what happens. Again, I did not prove this offline. I did the research and said, how is this being used in other places? And I found it. And it looks really simple. So we're going to try simple. All right, so there's our init. This is our first DMA, the A460 through the BNE. That checks to see if the DMA is completed. But the one that we were really having the problem with was the second loop here. Starting at this line. Is that right? This is the loop. All right. Okay, so at this point we have, I just let it run, so it is on this 106C, and so it should have at least attempted the first DMA. 1, 2, 3, 1, 2, 3, 4. All right, so it has not completed. Only a couple of instructions actually have run. So I'm going to let it run here for a minute. I'm going to do F9, set my breakpoint, F5. Oh. Remove that breakpoint. And it worked. So if we look, we can double check over here that the PC is the 8107C, 8107C. And so our DMA is completed. If we look at our window in the background, we can see the E return instruction at the 8000 mark, all of our A55s. We're going to scroll down a bit more here. Remember the 300 range? Oh, 180 has the other E return instruction, which is what we wanted. And then at 300, we're going to see a little gap. What are the odds? And that looks like our original data as expected. Very cool. And so originally it would start at the 320 mark and go up to 400. That's the second DMA that has not actually run yet. So we're going to just let that run. And so the way this DMA command is that it checks that it can do a DMA and then it does it. So it doesn't wait after the fact. So I am going to, so I set the breakpoint on the jump instruction, and we're just going to loop here a few times. We can see how many times down here in the list. I'm holding it down. You know what, I'm going to go ahead and remove this breakpoint and just let it run here. We can see some of these values up here in the corner changing. That means some stuff is happening. Oh, and if we look in our background window, I'm going to, there we go. I just used a function key. I think it was F9 to set a breakpoint. And if we look back here at the 320 mark, we are now full of the A55s. Again, all of our data goes up Here's the I'm going to say 8,000, but this is our 8 megabytes of RAM actually. That's what that's indicating. And then we have the 31C is that 0. So we have now populated all the way up to the 400 mark. And that is what we needed. Our code is now structured. All right. I am very happy with that. I'm going to wrap this video covering the BAS assembler instructions and how to use them and how to make the code layout like we want. Next steps, we're going to look at some instructions and what are we doing with these exceptions and interrupts? How are we going to handle them? All right. Thank you for your patience. This one took a little bit longer than I wanted. I'm happy to wrap this up in such a short little video. Thank you for watching.